All right, let's just get right into it. If you are building with AI agents, you know the feeling. They can fail silently, get stuck in a loop, or just do something weird. And for the longest time, the only way to figure out why was to stare at endless, soul-crushing text logs. Well, today, we're talking about the massive shift away from that pain and into the beautiful clarity of visual traces.
So here's how we'll break it down. First, we'll talk about that universal problem, what I call the agent debugging wall. Then, we'll get into the fundamental mindset shift from logs to traces. After that, we'll see how a tool called Arize Phoenix makes this all visual. We'll also cover why its open source nature is such a game changer, especially for startups. And finally, we'll look at the bottom line, building better AI way, way faster.
Okay, so let's set the scene. You know it, I know it. It's late, your super smart AI agent is broken, and it's on you to figure out why. You've just hit the agent debugging wall. And look, this quote from Evil Martians just nails it, doesn't it? You are suffering needlessly. This isn't just some small annoyance. For developers building real products, this is a massive, progress-killing bottleneck. And this right here, this is why. You're staring at this horrible wall of JSON. Somewhere buried in that sea of brackets and commas is the one clue you need, the one bad tool call, the one infinite loop, but finding it feels less like engineering and more like looking for a needle in a very, very boring haystack.
And the consequences are very real. Your agent fails silently, and you have no idea. A simple bug hunt stretches from minutes into a 4-hour ordeal. And that's a common story. And the cost? Oh, it adds up. Every time your agent gets stuck in a loop making redundant API calls, you could be burning hundreds, maybe even thousands of dollars. But worst of all, when your product acts in a way you can't explain, it just completely shatters user trust.
But here's the thing. What if the problem isn't actually your agent? What if it's the tools we're using to look at it? The real solution here is a fundamental shift in how we think, getting away from logs and embracing something called traces. So to really get this, you have to understand the difference. A log is like a single isolated note. It tells you what happened in one tiny spot at one moment in time. A trace, on the other hand, is the entire story. It follows a single request from beginning to end, across every service, every tool call, every LLM. It doesn't just tell you what happened, it tells you the complete story of how and why it happened. And the basic building block of that story is something called a span. Just think of a span as a single chapter, one function call, one database query. A trace is what strings all of these spans together, showing you the exact parent-child relationship, so you can see precisely how one action caused the next. Now, traces are a fantastic concept, but a long list of spans isn't much better than a long text log. So how do we actually make sense of them? Well, this is where a tool like Arize Phoenix comes in and turns all that complex trace data into actual, actionable insight.
Because that's the real question, isn't it? A single agent interaction could fire off hundreds of operations, creating hundreds of spans. If you just look at that as a list, you're right back where you started. So how do you make it, make sense to a human brain?
And the answer is just brilliant. Phoenix takes all those little individual spans and automatically builds what it calls an agent graph. It's basically a map of your agent's thought process. And suddenly, the chaos becomes clear. You can visually see the paths it's taking, instantly spot where it's getting stuck in a loop, and see exactly which agents are calling which tools. It's a total game changer. So what Phoenix does is cool, but what's really important is how it's delivered. We're not talking about some ridiculously expensive, locked-down enterprise platform. This is all about bringing that power to everyone and democratizing AI observability. Just look at this breakdown. Phoenix is free and open source. You can self-host it, which is huge. It means your proprietary data, your prompts, your models, they all stay within your control, on your infrastructure. You're not shipping the brains of your operation to some third-party black box. For any company, but especially an early-stage startup, that combination of power, cost savings, and data control is just massive. And it just works with the tools you're already using. LangChain, Llama Index, OpenAI, Crew AI, you name it. It has built-in support for pretty much the entire modern AI stack. You don't have to rebuild everything. You can just drop it in and get started. So, let's bring this all home. What's the real-world impact of making this switch? What happens when you go from reading logs to seeing traces? Well, it all comes down to two things: speed and reliability. This number pretty much says it all. An 80% reduction in time spent debugging. Just stop and think about that. For a small startup team or even a solo dev, that is an insane amount of time you get back to actually build new features instead of just fixing what's broken.
And here's what that 80% actually feels like for a real person. A 4-hour debugging nightmare becomes a 10-minute fix. That's not just a small improvement, that is a fundamental transformation of your entire development workflow. So the big takeaway is this: visual tracing lets you ship reliable AI products so much faster. And by making these kinds of enterprise-grade tools open source, platforms like Phoenix are really leveling the playing field. They're giving solo developers and growing startups the power to build truly robust and trustworthy AI that can compete with anyone. So in the end, it really comes down to a very simple choice. When, not if, your agent fails, do you want to spend your next few hours reading text, or do you want to spend the next few seconds seeing exactly what went wrong? I think the answer is pretty obvious.